very important problem from area of a plane curve, and the problem is so that area included between the curves, the first curve is given by x square plus 2y square, this is equal to 4, and the second curve is given by 2x square plus y square equal to 4, and the answer also given, this is 8 root 2 sine inverse 1 by root 3. And if we rewrite this two curve looks like this is x square by 4 plus y square by 2, this is equal to 1, and the second curve is x square by 2 plus y square by 4, this is equal to 1. Okay, so for this curve the major axis is 2 and minor axis is root 2, and for the second curve this is major axis is also 2 and minor axis is root 2, but the major axis here along the x-axis, here major axis along the y-axis. So we draw first two ellipses. These two are ellipses. We draw a rough sketch for these two curves. The first curve is given by like this. This is the first curve. Okay, and we know that this point is 2 0, and also this point is minus 2 0. Okay, and here we get this is the major axis, the length of the major axis is 4 and semi major axis is 2, and O, this is 0 0, this is the center of the ellipse, and this is x axis, this is y axis. And for the second curve it is clear that this curve is look like this type of curve, the second curve. Okay, this is also ellipse, and this point is given by 0 2 and this is 0 minus 2, right? And clearly this point is root 2 comma 0, and this is also minus root 2 comma 0. Okay, minus root 2 comma 0. We have to find out included area of two curves like this. Okay, and it is clear that there are same portion or same area of included curve or same area in 4 quadrants. So if we find area of one quadrant, then if we multiply it by 4, then we get our answer. Okay, because two curves, this and this, are symmetric about x-axis and y-axis. So we only find out the area included in the first quadrant. Okay, so we first find the point of intersection, that is the point A. To find out the point of intersection, we put the value of x square here. We get, this is given by 2 into 4 minus 2y square. We put here x square, so 4 minus 2y square plus y square, this is equal to 4. That is 8 minus 4y square plus y square, this is equal to 4. That is 3y square, this is equal to 4, and we get y, this is equal to plus minus 2 by root 3. Okay, and from here we get x square, this is equal to 4 minus 2 into y square, that is we get 4 minus, this is 2 into y square means 4 by 3, and we get 12 minus 8 by 3, this is 4 by 3, so we get x, this is equal to 2 by root 3, also this is plus minus, and we get 2 points. The first point is 2 by root 3 comma 2 by root 3, also we get the LS point. We cannot write this. Okay, now we draw a perpendicular on x-axis. This is perpendicular. Okay, we find the area of the first quadrant and we clean the area on the other quadrant. Only we set the area in the first quadrant we want to find out. Okay, then we multiply it by 4 and we get the area of the shaded portion. We first find the area of this portion. Okay, And how to find the area of this portion? Clearly, since this is the perpendicular and this is let AB, the point B, the coordinate of B is given by 2 by root 3 comma 0. Okay, so we find the area, required area is given by 4 into, we get first integration x equal to 0 to 2 by root 3, and this area under this curve and x-axis, and this curve is given by the first curve. Okay, so we find out the value of y from here. We write first y dx. Here y means x square plus 2y square, this is equal to 4. Okay, now we add the extra area, this is the extra area. Okay, we set this portion by different type of street, and for this area we integrate this curve, that is the second curve, and here the range of integration is 2 by root 3 to root 2. Here x equal to 2 by root 3, here x equal to root 2, and this is y dx also, but here y is 2x square plus y square, this is equal to 4. Right, now we put the value x equal to 0 to 2 by root 3, we put the value of y, this is given by root under 4 minus x square by 2, that is we write here 1 by root 2. Okay, y is 4 minus x square root by 1 by root 2, this is dx. And for the second curve we get 2 by root 3 to root 2, and we write the value of y, this is given by 4 minus 2x square dx. Okay, now 4 into 1 by root 2, this means 4 by root 2 for the first integration, this is 0 to 2 by root 3, and this is given by 2 square minus x square dx. And from here we take common 2, that is root 2, we write here root 2 into 4, already here in outside of bracket we get integration 2 by root 3 into 2 root 2 root under root 2 square minus x square dx. Okay, and we put the formula on both the integration, same formula, 4 by root 2, this is x into root 4 minus x square by 2 plus a square by 2, this is 4 by 2 sine inverse x by a, this is x by 2. Here the ranges are 0 to 2 by root 3. And for the second integration 4 root 2, here also the formula are, this is x into root 2 minus x square by 2 plus a square by 2, this means 2 by 2, because root 2 square by 2 into sine inverse x by root 2. Okay, and the ranges are 2 by root 3 to root 2. Now we put the range of integration and getting the result as, putting the upper range we get the first integration, from the first integration 4 by root 2 into, from here we get 2 by root 3, 2 by root 3 into root under 4 minus 4 by 3 by 2, by putting 2 by root 3, and by putting 0 we get 0, and so we write the second term, this is plus 4 by 2, this is 2, and we get, by putting this we get sine inverse, this is given by 2 by root 3, this means 1 by root 3, 2 to cancel out, and by putting 0 we get 0. For the first integration we get this result, and from the second term we get 4 root 2 into, here we put root 2, then we get 0, okay, because 2 minus root 2, and for the lower integration or for the lower range we get the result, this is minus 2 by root 3 into root under 2 minus 4 by 3 by 2. Okay, and from the upper integration from here we get plus sin inverse 1, we directly write pi by 2, minus by putting 2 by root 3 here we get this is minus sin inverse root 2 by root 3. Okay, because if we put x equal to 2 by root 3, root 2 cancel out, then we get 2 by root 3. This result we get from both the integration. Now calculating, we get 4 by root 2 into, from here 2 to cancel out, 1 by root 3 into, this is 12 minus 4, this is 8 by root 3. Okay, 12 minus 4, 8 by root 3, that is 2 root 2 by root 3 plus 2 into sin inverse 1 by root 3. Now from this integration we get 4 root 2, we write pi by 2 first, then we get minus 2 by root 3, and this is into half because there will be a 2, and from under root we get root 2 by root 3, right, and we get this is minus sin inverse root 2 by 3. Okay, now we taking common from here, 2 taking common. Okay, so we get 8 by root 2 into, this is given by 1/3 plus sin inverse 1 by root 3, and from this term we get this is plus 4 root 2, this is pi by 2 minus, from here we get 2 to cancel out, root 2 by 3 into sin inverse, sorry, this is root 2 by 3 another term, and this is minus sin inverse root 2 by 3. Okay, now from this first term and this second term we get the result as, here we make a small mistake, this is 1 by root 3 into 2 root 2 by root 3, this is given by 3, and this is 2 root 2. Okay, now here we take common 2, so here remains another root 2. Okay, now if we multiply 8 by root 2 into root 2 by 3, this gives 8 root 2 by 3 into root 2, so this gives 8 by 3, and also from here we get 4 root 2 into root 2 by 3, this is also 8 by 3, so this is plus 8 by 3 and this is minus 8 by 3, so both the value are cancelled out. So from the first term we get 8 by root 2 into sin inverse 1 by root 3, and from here we get this is 2 root 2 into pi, because 4 root 2 into pi by 2, this is 2 root 2 into pi, and from here we get this is minus 4 root 2 into sin inverse root 2 by 3. 2 and 3 both are in the root. Now we take common from this sin inverse and this sin inverse, we get this is given by also 4 root 2, because 8 means 4 into 2, root 2 cancel out, so we take common 4 root 2 from here and here, we get this is sin inverse 1 by root 3 minus sin inverse root 2 by 3 and plus 2 root 2 into pi. Okay, so we use the result or use the formula sin inverse x minus sin inverse y. Now the formula of sin inverse x minus sin inverse y is given by sin inverse x into root 1 minus y square minus y into root 1 minus x square. Okay, we put in the formula 4 root 2, this is sin inverse, this is 1 by root 3 and this is root under 1 minus 2/3 minus this is root 2 by 3 into root under 1 minus this is 1/3. Okay, and plus 2 root 2 pi remains fixed. Okay, so from the first term, or we write first term as 2 root 2 into pi, and the second term as this is plus 4 root 2 into sine inverse. We get from here this is 1 by root 3 into 1 by root 3. So this is 1/3 minus from here we get this is root 2 by 3 into root 2 by 3. So this is 2/3. Right? So we get the result as 2 root 2 pi plus 4 root 2 into sine inverse. This is minus 1/3. Okay, so we get the result as 2 root 2 pi this is minus 4 root 2 into sine inverse 1/3. Okay, now we taking common from both the term 4 root 2, then we get, and right here 4 root 2 we taking common. From the first term we get this is pi by 2, and from the second term we get minus sine inverse 1 by 3. Okay, so we get 4 root 2 into pi by 2 minus sine inverse x, this is cos inverse 1 by 3. Hence we get our result, that is the required area, in the form 4 root 2 into cos inverse 1 by 3. But this is not in the form of our given answer. To convert into it to our given answer, we put here, we first write this result as this is 4 root 2. We convert cos inverse, this is given by the sine inverse. Okay, so we put first cos inverse 1/3, this is equal to theta. Then we get cos theta equal to 1 by 3. So we get sin theta, this is equal to 2 root 2 by 3. Okay, so we get theta, this is equal to given by sin inverse 2 root 2 by 3. So we write the result as sin inverse 2 root 2 by 3. But also this result is not in the given form, and to take the given form we put here sin inverse 2 root 2 by 3, this is given by 5. So we get 2 root 2 by 3, this is equal to sin 5. Okay, and we expand it, this is 2 into sin 5 by 2 cos 5 by 2. Okay, and now we find the value of cos 5 by 2, and we now cancel out 2 and 2, then we get here root 2 by 3. Okay, and 2 cancel out. Now we find the value of cos 5 by 2. What is the value of cos 5 by 2? The cos 5 by 2 is given by, from this result, here we take sin 5. Sin 5, this is equal to 2 root 2 by 3. Now from the value of sin 5, we get the value of cos 5. This is cos 5, this is equal to root under 1 minus 8 by 9. So this is 1/3. Okay, now we expand, or using the formula of cos 5, this is given by 2 into cos square 5 by 2 minus 1. So we get cos square 5 by 2, this is equal to half into 1/3 plus 1. So this is 4 by 3 into half, that is 2 by 3. Okay, and that is cos 5 by 2, this is root 2 by root 3. Now we putting the value of cos 5 by 2, we get this is sin 5 by 2 into, this is given by root 2 by root 3, and left side is root 2 by 3, and cancel out root 2 and root 3 cancel out, there remains root 3. So we get sin 5 by 2, this is equal to 1 by root 3, and this result gives us 5 by 2, this is equal to sin inverse 1 by root 3. That is 5, this is equal to 2 into sine inverse 1 by root 3. Okay, and now putting the value of phi. Okay, phi means 2 into sine inverse 1 by root 3, and we take this value as phi here. We get this value as phi here, so we put here the value of phi. This is 4 root 2 into, this is 2 into sine inverse 1 by root 3. Okay, so our final result is 8 root 2 into sine inverse 1 by root 3, and this is our final answer, and this is our required answer also. Very important problem of area of plane curve. Thank you for watching.